Now, this for the Math 30s, we just kind of went through this. So it's going to be about 95% review. The only thing is, when we do it in 30-1, we're not doing it to draw a graph. Okay, we have a graphing calculator to draw graphs, right? So this stuff we're using as more evidence to pick up to be able to draw this. So we do it a little differently as far as how we find our horizontal asymptotes. Now, if you are finding horizontal asymptote, you're really trying to find out the limit when x goes to infinity, right? But let's face it, there isn't just infinity we want to test. We also want to test negative infinity. We want to test both directions, because there is sometimes that if I put x as infinity in there, the equation goes to infinity. So you can see what that's going to do. Okay? It's not going to have one on that side. The other one could go to negative infinity, which means, oh, it's going to be going down. Okay? So that helps us to draw. So we will do two limits for these as well. We will do positive infinity of f of x, and it should go to some sort of asymptote. So as x approaches infinity, f of x gets closer to finite value L. So this is saying as x goes to infinity, this is approaching whatever that may be, 5, 2, right, 9 over 2, whatever. And so we kind of never really looked at it that way. We just kind of put, well, the stuff that we're going to do in a bit, that, you know, if the top degree is bigger than the bottom degree, it's going to infinity. If they're the same, then we cancel them out and we use the, right? But we never have really put in infinity, and we've never put in negative infinity. So that's where it's just a little different, because it's going to help me with my drawing. So limit as x approaches negative infinity of f of x equals L. So that's the picture right here. This is approaching negative infinity. So the only times that really I found that it actually, like just about every time, if it goes to like 2/3 on the one side, it goes to 2/3 on the other side. Or if it goes to 0 on one side, it goes to 0 on the other. But it's when it goes to infinity on one side, does it go to infinity on the other side, or negative infinity? Okay, that's what we, so like if I gave you this example, y equals x squared, right? Like if you put negative infinity in there, it goes to, right, infinity. If you put negative infinity in there, negative infinity squared is infinity, right? So I'm using that evidence there. Now what about y equals x cubed? Well, if I put in infinity, it goes like this. If I put negative infinity cubed is negative infinity, right? So that's where that does give me a little bit more insight on, hey, what does this graph look like? Now you could also say, well, I should have known that, because a cubic is going to start low and end high. But this is one more thing to verify, okay, I got that right. Okay, that's what I was thinking. Okay, so if R is a positive rational number and X over R is defined for all X, then, oops.
Announcements will start in 10.
Okay, so this is just saying if you have limit X goes to positive infinity of 1 over X to the R, this would go to 0. If you had limit X goes to negative infinity, 1 over X to the R, you would get 0. Okay, so now this one here, do you see that they are both the same? So if you put infinity or negative infinity in there, what would be the horizontal asymptote? 9 over 2. So we'll just write the shortcut that I think we just used. If top degree equals bottom degree, use the highest coefficients. Okay, so we've done this in 30, 31 before, and one more time, right? So this is not new for you. Okay, now if you have this number is going to be much bigger than this number if you put infinity in there, right? So if it's bigger on the bottom, it'll turn into 0. Okay, so this equals 0. So the shortcut, if top degree is less than bottom, it approaches 0. And again, see this one, if you put negative infinity over negative infinity, right? Or if you put negative infinity there, you're still going to get 0. So I find the only time it helps to put in negative infinity as well is if we're doing, well, you're going to see in a sec, I guess. I'll not give away the ending. Okay, now this one here, if I have 20 x to the 7 over 160 x to the 4, okay, this limit would go to, okay, infinity. So the shortcut, if top degree is bigger than bottom, goes to infinity. But again, this one, I would check negative infinity as well, because it does sometimes give a different answer. It may give negative infinity, which in this case, it does, right? Because I'd get a negative infinity over a positive smaller infinity, right? That makes sense? Okay, but so here are the 4 possibilities for limits at infinity. So this would be as limit x approaches. Now, in this one, see x is approaching positive infinity, right? So x approaches positive infinity. This one is going to positive infinity. Okay, the one beside it here, this one's going also to positive infinity, but this limit as x approaches positive infinity is going to negative infinity. Now give me an equation that would give a negative infinity. What's a good example? You're putting positive infinity in there, and you're going to get negative infinity as an answer. Well, that one's, yeah, pretty obvious, yeah. Negative 1x, right? Would that do it? Yeah, okay. Or negative 1x to the 7, that's not a rational expression, that's the only thing, but over like x to the 4, okay, that would give. Okay, now we got limit as x goes to, we're going to negative infinity here. This one is going to, oops, of f of x equals positive infinity. And this here too, we are going to negative infinity. So limit as x goes to negative infinity equals negative infinity. Okay, now I've kind of given you these two scenarios. If you put in the limit as x goes to positive infinity, it will equal positive infinity. If you put the limit x goes to negative infinity squared is positive infinity. Oops, I should put the actual limit here, right? Equals positive infinity. Now this one here, if I had limit of x cubed goes to positive infinity, that would equal positive infinity. But the limit as x goes to negative infinity of x cubed, negative infinity x cubed would be negative infinity. So that does kind of verify, I think, that if you have knowledge of, hey, that should be a cubic, so it should start low and high. Okay, that's good too, because my infinity statements show that. Okay, this is just an example. We'll just do this one quick. Now, first of all, let's just talk about what would be the vertical asymptotes of 1 over x? 0. Okay, so if we're just going to draw a graph, we have this. Okay, and then we have, do we have any x-intercepts? Any x-intercepts? No. Any y-intercepts? Because you can't make x equal 0, right? Okay, so we got no x-intercepts, we got no y-intercepts. We have a vertical asymptote at 0. So really, it's pretty hard to draw this right now, unless we do our horizontal asymptotes. So horizontal asymptotes will do limit as x approaches positive infinity of 1 over x. That would equal 0. Limit as x approaches negative infinity of 1 over x would equal 0. Now, can you go through horizontal asymptotes? Yes. How do we know that we're not going through this horizontal asymptote, which is right there now? How do we know? No x-intercept. Okay? So we know we're not going through it. So this would be our possibility for this one. Okay, so this one we're dealing with, and if you, when you get good at these, you're going, well, how come it couldn't be like this? Okay, well, how can it not be that way? It's a good question. Okay, so maybe we needed to do a better job with our vertical asymptotes, right? We should have approached 0 from the right side and see if it approached negative or positive infinity. All right, so That shows you too how you can mix it up if you don't test everything. But okay, so this one, we're going to do this question, I guess, with everything we now know. Okay, so we're going to try and draw this entire thing without the use of a graphing calculator, which is our end goal by the end of this unit. With just a couple more things, we're going to be doing slant asymptotes yet, and concave up, concave down, and then we're pretty well done this unit. Okay, let's do the vertical asymptotes. Okay, so what's the asymptote? So x equals -2 is our asymptote. So we want to do the limit as x approaches -2 from the left of f of x. Okay, so what is -2 from the left? 2.0001. Okay, so that is definitely going to give me a negative upstairs. Down would give me what in brackets? Small negative, so small negative, but I'm squaring that. So that'll be a negative over a small positive, which would equal -infinity. Okay. Now how about the limit as x approaches -2 from the right of f of x? Okay, and we're thinking -1.999, right? So that's going to give us our positive up top over our small positive on the, oh, sorry, what am I talking about? Yeah, negative on top over small positive, which would still be negative over small positive. So that's going to be, so when it hits the asymptote, where the arrow is going to be pointing? Both of them will be pointing down, right? So if we just need to, we should be getting this scenario. Okay, let's do horizontal. So now for this one, I would try and actually, just to get my x squared plus 4x, oops, not x over, x squared plus 4x plus 4. The reason I'm doing that is because I can use my rules, right? So the limit as x goes to, let's go positive infinity of f of x, what would this equal? 0. Now you can see if you went, now if I got infinity here, I would be testing my negative, okay? But I'm going to do it anyway as x goes to -infinity of f of x. You can see you'll get 0 as well. Okay, so then I'm looking at something like this, right, where it's approaching zero is my horizontal asymptote. Okay, so intercepts. Okay, so let's do y-intercept. Remember, that's when x equals 0. So y equals 0 over 0 plus 2 squared which equals 0. So my y-intercept is 0, 0. Okay. X int y equals 0. So 0 equals x over x plus 2 squared. Just by looking at it, what would x have to be? So x equals 0. Because if I put a 0 on top, it'll all make it. Okay? So it's going through. That's the only x and y intercept. Okay, next, let's do max min. Okay, now we could pull out the old quotient law, or we can cheat and just go x times x plus 2 to the negative 2. They're probably both the same amount of work, but people like the... Okay, so y prime equals first times the derivative of the first times the second plus the first times the derivative of the second, which would be, derivative of that second would be what? Negative 2 times, and I'm just going to put times the 1 so I remember to do the chain rule, right? Because you got to multiply, or you got to do the derivative of x. Okay, so what do I got here? I got, and that's why actually the quotient rule is nicer, because you don't have to go through this. But you can see I have a common factor here that I can take out. So I will take out x plus 2 to the negative 3, which would leave me with x plus 2 and a negative 2x onto that one. So y prime would equal x plus 2 to the negative 3 times 2 minus x, which would equal 2 minus x over x plus 2 cubed. Okay, CVs are where? What are my critical values? Yep, 2 for the top and negative 2 for the bottom. Now, this is going to be kind of new for us. You always want to put on your y prime, you want to put obviously your critical values. So you got negative 2 and 2. But one thing that you should always also be putting on your number line is your asymptote. So why does that help me? So I know there isn't a max or min at that point. Right? There's no value at that point, so how can I find a max or min at negative 2? But I could still, it'll still help me to find out what's going on. Okay, so test values. Try negative 3. Okay, so 2 minus negative 3 would be positive. And I've got negative 3 plus 2 is negative. All cubed is negative. So I have a negative there. So I'm falling, right? Let's pick 0 as my test value here. 2 minus x is positive. And 0 plus 2 cubed, it would be positive. So this is positive here. So it is rising. Okay, let's try 3 over here. 2 minus 3 is negative. And 3 plus 2 cubed is positive. So we have a negative. So what I have often seen is people will say there is a minimum at -2 and a maximum at 2. Okay? Because you kind of forget the rest of the information you already did. So that's why I always draw my asymptote in there, and then I know, okay, it's going to go down there and then start coming up the other side. I get that. But it's not going to be a minimum because that point doesn't exist. So we have a local max at two. Okay, and if you put okay, good. Always go back to the original. I mean, you'll know because if you put in 2 into your derivative, you get 0, and you're like, huh? How's that be a maximum, right? But sometimes it coincidentally could be, or it could look like a maximum, so you're gonna go for it. But we got to go back to the original, which is x over x plus 2. So that's 2 over 16, which is 1/8. So 2 comma 1/8. Okay, so we got everything we need. Let's draw it. Okay, so what do I know? I know that I have a asymptote at -2. So here's -2. Draw my vertical in there. And I have a, so you can write VA there. I also have a horizontal asymptote there. Now, from -infinity to -2, what are we doing? From -infinity to -2, what are we doing? We're going down, okay? Are we crossing the asymptote there? No. Okay, so this should look something like this. Okay, now on the right side of the asymptote, it is increasing to what point? All the way to 2. Okay? But am I going through the asymptote or not? I am going through the asymptote. Why? Because I do have a y-intercept and an x-intercept at 0. So this is y-int and x-int. And I'm going to find a max at 2 comma, say like 1/8. And as I go to infinity, I'm going to be leveling out to 0. So just kind of want to have a max there, and then does that make sense? Awesome. Okay. Okay, so let's just answer these questions together. And okay, so as x is going, that's saying it's going to -6 on the right side. -6 on the right side, what is it approaching? -infinity. Okay, so we're coming this way. It is going to -infinity. How about as x is approaching -6 from the left? negative infinity. So, is there a limit at negative 6? Yes, and it is negative infinity. Remember all the way back to limits, if it exists from the left side and the right side, and it's the same limit, then limit does exist at negative 6. Okay, let's do 2 from the right. So as I'm coming from the right, where am I going? Positive infinity. From the left, negative infinity. So what is the limit as x approaches 2? Does not exist because left-hand limit does not equal right-hand limit. Okay, as limit is approaching negative infinity, what's this graph? As we're going this way, what's the graph approaching? 4. Because you can see this. Okay, and as it is approaching positive infinity, negative 8. What's that? Negative sideways infinity. Okay, so page 222, 1 to 5.